Okay, so in this video, we're going to go over how to find equations to different graphs using their general forms and locator points. All right, so this first graph, we want to recognize it is a cubic function. And so the general equation you want to use for cubic functions is y equals a times x minus h cubed plus k. So in these equations, the hk values represent the locator points, so specific points on every graph. On a cubic function, a locator point is the inflection point, which is right here. So that point is labeled as negative 1, 4. So we're going to use negative 1 for h and 4 for k. Now in any function, the x, y values as a point give you any other point on the graph. So in this case, we have another point labeled 1, negative 20, so we'll use that as our xy values. So what we do is once you recognize and locate the locator point and another point on the graph, we're going to insert those values from each point into the general form of the equation. Then we're going to solve for the a value, which determines orientation and how it's being stretched or compressed vertically. Once I have a, along with hk, since those are parameters, I can then write the equation of that graph. So here we go. We're going to let y equal negative 20. That's from the point that is not the locator point, it's y value, equals a. I do not know, so we're going to leave that alone. Parenthesis, x is 1, which is the x coordinate of the non-locator point, minus h. So since the locator point's x coordinate is negative 1, h always lies, so we're going to put a plus 1 inside the parentheses. We always do the opposite inside the parentheses when it comes to h. The k is 4, so we're going to put that out back. Once I have this, I am going to go through and we are going to solve for a. So the first thing we'll do is we'll move the forward by subtracting it. So negative 20 minus 4 is negative 24. And then we're going to actually figure out what the parentheses cubed equals and then multiply that by a. So 1 plus 1 is 2. 2 cubed is 8. So 8 times a, is 8a. And to solve for a, we're going to divide both sides by 8. So the answer for a is negative 3. Once I have a, h, and k, I can write the equation of that graph as y equals a negative 3 times x minus h. Again, h is negative 1, so you put a plus 1 there, cube it, and k is going to be 4. So the equation of that cubic function is negative 3 times x plus 1 cubed plus 4. Okay, let's look at another graph. Okay, so this graph is a square root graph. So the general form of a square root equation is this. The k is not underneath the root. All right, and so in a square root function, the hk, or the locator point, is the point where the graph seems to begin or end. So in this case, it would be the point negative 9, negative 4, this point right here. So we're going to let h be negative 9, k be negative 4, and we need to find another point on the graph. So we see 7, 4 is labeled. So we're going to let that be xy, and again, we do not know a, so we're going to find it. Same exact idea as the last video, so the last problem. So if you need to go back and rewatch that, great. If not, I would challenge you to pause this video right now and try to find this equation. Okay, so y is 4 times, I don't know a, x is 7, minus h is negative 9, so again opposite, so plus 9, and k is 4, so we're going to put that negative 4 out back. Same idea, so as last time, we'll take the negative 4, add it to 4, gives me 8. Then we're going to figure out what the square root equals. So 7 plus 9 is 16. Square root of 16 is 4. 4 times a is 4a. And we'll divide both sides by 4. We get a is 2. A, h and k, so I'll write my equation to my square root function as y equals 2 times the square root of x minus h, so again plus 9, h lies, and then the negative 4 goes up back. So the equation of this square root function is y equals 2 times the square root of x plus 9 minus 4. Okay, last one here. So this one is a rational function. So there's lots of ways to write this one, but I like to use this format as y equals a over x minus h plus k. So in a rational function, the locator point is the intersection point of the two asymptotes. So using that knowledge and how the graph is labeled, pause the video and try to find the equation of this hyperbola yourself. Okay, so the intersection point is here. That's this point here. So we're going to let h be negative 2, k be negative 3. This point is our other point, so we're going to let that be x and y and start plugging it in. So y is negative 2.25. That equals a. I do not know a yet. X is 2. H is negative 2, so minus a negative, again, opposite gives me positive. And then k is negative 3. So what we're going to do first is we're going to add that 3 over. So negative 2.25 plus 3 is 1.25. Then this is a fraction, so we're going to leave the a alone and figure out what the top is. So the bottom, sorry, so 2 plus 2 is 4. And then to solve equations like that, we just multiply everything by 4, or whatever the denominator is. So we get 1.25 times 4 gives me 5. And that gives me a, so a is 5. And so my equation would be y equals 5 over x plus 2 with the minus 3 out back. All right, so hopefully this gives you some insight in how to write equations to different graphs based on their general form. If you like this video, you found this helpful, please help me out by liking this video by hitting the thumbs up or the like button at the bottom of the video. Thanks for your time.